Today we're going to continue the discussion of what we did last time, which was finding the clearance between two lines. And we'll do one more exercise just to practice that same concept, but then you guys are going to apply that concept to two pipes. So instead of just being arbitrary lines, these lines now represent the center lines of pipes. And then we'll find the clearance between two pipes that cross over each other. So a couple things to point out about this that's going to be a little different. First of all, now that we're dealing with pipes and not just lines, we're going to have to solve for visibility, meaning that either this pipe is on top of this one and I've got to trim out the lines in that one, or this pipe is on top of the other one and we've got to trim out the lines of that one. So we'll talk about exactly how to figure out the visibility in just a couple minutes. And then the other thing I want to point out is that on our point view, we're still doing the same concept, which is we've got two lines. We want to find the true length of one of those two lines so that we can then find the point view of that line. But now the point view is not just going to be a point, it's going to be a circle. It's going to be the end of that pipe. Other than that, in finding the clearance, it's going to be pretty similar to what we did last time. So as usual, I've got a sample file that we can work with first. So if you go to New, and then our Templates folder, and then the Additional Files folder, then there's one in here called Pipe Clearance. So in each of these cases, these pipes actually represent a longer pipe. This is just where they cross over. They wouldn't necessarily have a square cutoff. They'd be foreshortened and we'd see a rounded end. But to keep things simple, we're just kind of squaring them off here. But then in terms of projecting things, I'm still just going to really look at that center line and use those endpoints. So I've got line AB and line CD, and as I can see, I don't have any parallel relationships, so I'm going to have to construct one. So I'm going to start by finding the true length of AB, since I've got some room up here. So I'm going to create a hinge parallel to AB. Now the center line and the white pipe lines are parallel to each other, so I can just go parallel to any of those three, really. It will let me. There we go. Let's try that again. There we go, that's better. Alright, so once more I'm going to use my ray and project A and B across. Now you might see the midpoint snap when you grab those, since it's the midpoint to the little white ends. And then two views back for my offset. So A is my close one, and again, just make sure you're taking the ends of the red lines. Oops, and then B is the far one. So I'm going to use my center line type and create my center line. Just the red center line is all we're doing right now, the endpoints of the red line. So again, you don't have to copy your labels over on this particular example. I'm going to, while I wait for some of you to get to the same spot. So I have A1 and B1. And that, of course, will be true length. You don't have to label it. You can if you want, if it helps you remember which one's your true length line. So now I'm going to bring C and D across. Again, using the same steps that we've been using most of the semester. So there's my C and D rays. And then two views back for the offset. D is the close one. And C is the far one. pipes. Now I can apply the pipe thicknesses as I go. I'm going to wait and just deal with the center lines right now, and then I'll do the pipe thicknesses at the very end. So now I've projected these two lines, and again, AB is my true length one, so I'm going to go perpendicular to that to get the point view. So again, just a line perpendicular to that one. Looks like I accidentally changed this one into the hinge lines layer. And this should be in the hinge lines layer. And I'm going to use my lengthen to stretch that out a little bit. All right, and then we'll start projecting. So AB should give us a point view. So I'm going to start a point at A perpendicular to the hinge. It crosses through B, so that's good news. Go 2 views back, and I'm going to offset from the center line of AB to this hinge. A and B are both the same. That's what's going to give me a point view. And then again, labeling wise, since B is the closest, then I will have B2, A2. And then now I'll take C and then, oh, looks like I goofed up some labeling. This was C and this was D. There we go. So now I'll take C and D across. And then 2 views back from my offset. D is the close one. C is the further one. So there's D and there's C. I'm going to go ahead and do my perpendicular connectors, partially just because it's easier to project back in all the views, and really it's easier to think about the fact that your perpendicular connector is between center lines. So it's not just between the pipes. You're going to be connecting the center lines anytime you draw your perpendicular connectors. So if I start with I'll use my object line here. It's just going to go from this point perpendicular to line CD. And what we did last time, that would be the value that we would have measured, but we're going to apply the pipes to it in just a little bit. So for now, we're just drawing our perpendicular connectors. So that made a new intersection here at CD, so we will project that back. Where that hits CD, we'll draw perpendicular to AB, since AB is true length in this view. And then we'll now take both of those intersections back to the previous view. Excuse me. So grading the assignments the other day, there were a few missed points, and usually it was because of a situation like this where when you get to this view, do I connect this line, this intersection to that intersection, or that intersection to that intersection? So there were some people that got those backwards. So if you're doing more than one at a time, make sure you keep straight which one's which. So this one up here is starting at AB, so I'll make sure it starts at AB down here. And therefore the other line goes to CD right there. And then now I'll take those two intersections down. And again, try to keep straight which one's which. AB is the one on the right, and CD is the one on the left. So before I do the pipe stuff, is a vertical connector possible on this one? No. They don't cross on the horizontal plane, so no vertical connector is possible. Okay, so now we're going to apply the pipes, and we need to figure out how big these pipes are. So I'm just going to use my dimension tool and dimension CD to find that it is a diameter of 10, and AB is a diameter of 6. So I'm going to apply those in these views. So I'm just going to start with the last one over here. B2A2 is a diameter of 6 or radius of 3. So I am going to draw a circle with a radius of 3 at this center. That represents the point view or the end view of pipe AB. Then for line CD, I'm going to offset 5 in each direction so that I'll be able to get the 10-inch diameter pipe, if you will. So offset. Now I already did the offset and set mine up to offset into the current layer. That way, since object lines is already current, it should put it right into that layer for me. So I'm going to put 5 as my value, and I'll offset each direction. If you don't do that, then you might have to manually adjust those. And then I'm going to cap each end just by drawing some lines. This one? Yeah, I offset 5 each way to get that diameter of 10 altogether. And so if we come back to the previous view, then we're going to offset both of these. So CD is 5 again. Since it remembers my last value, I'm going to go ahead and do CD first. And again, you can just cap those with a straight line. And then AB, I'm going to offset 3, the radius value of that pipe. And then once more, I'm just going to cap those ends. So I'm almost done. What I want to do first of all is figure out what the clearance value is. So the clearance value is going to be from this intersection here to this intersection here, rather than going from center to center. So I'm just going to use my aligned dimension tool, snap to that intersection and this intersection, and there is my clearance value. So if I needed to fit another pipe between these two, I now know the space that I have in there to do so.
You went to the center. Did you see it? Okay, good.
Okay, so we're not quite done yet because the last thing that we need to do is we need to solve for visibility. So the way that we solve for visibility is, first of all, remember what these hinges mean? These hinges are just 90-degree folds. So I want to figure out which of these pipes is on top of the other. And the way that I figured that out is I start at their intersection. And I take this intersection and project it into the next view. Whichever it hits first is what's on top. So I'm solving for this view right here. I'm going to start a ray at the intersection of these two center lines. So a ray at the intersection of these two center lines, and then project perpendicular to the next view. Whatever it hits first is what's on top in the view where I started my ray. And I can double check that. I should get the same answer if I take this intersection perpendicular this way. So in both cases, it hits AB first. So that means line AB is on top in this view. So I'm going to use my trim command, and I'm going to pick the top and bottom white lines of line AB and press enter, and then I'm going to trim out line CD. Don't worry about trimming the center line out. Go ahead and leave that there. We're just going to trim the outside lines. So now, after I get rid of my rays, it's clear to see that pipe AB is on top of CD. Obviously, this view doesn't need solving since they don't cross over each other. But as I look at the front view, I need to figure out which one's on top. So once more, if I start a ray at the intersection of the center lines and project up, which pipe does it hit first? CD. So CD is on top in this view where you started your ray. And that's important because a lot of people, like some of the missed points on these exercises is projecting into the next view and then trying to trim this view up. So you're trimming wherever you started your ray. So CD is on top, so I'm going to come back and trim and use the CD lines as my cutting edges and press enter, and then I'll trim out the AB lines and then erase my ray. So I have now shown my perpendicular connector in each view. I've calculated what the clearance between these two pipes is, and then I've solved for visibility. So those are the steps that you'll be doing today. And I think I've got a solutions layer up here. I can't remember. I do, but I don't have anything in it. I think this one, I think I might have actually saved it as a drawing in that folder. Let me double check here. Maybe I didn't put a solution up for this one. But if you have any questions, if you didn't get through that all with me, just let me know. So the ones I'd like to have you do today, we're going to skip one. So last time we did 3 and 4. We're going to skip number 5, mostly because it ends up with very short connectors and it's a little hard to work with. So we're skipping over space 5. We're going to space 6. And this is pretty similar to what we did last class period. Show the vertical, if one is possible, and the perpendicular connectors in each view. Dimension the shortest connector in the appropriate view. So you're to label all the PC and the VC, and then you're also to dimension the shortest connector in the appropriate view. So 2 problems to do that with. Make sense? So, I'm sorry?
Is this the only one?
This is the only one with lines, and then we're going to do 2 with pipes. So then space 7 are a couple of pipes crossing over each other. So you are to find the clearance distance between those 2. I do have a little spot up here where you can type in the clearance value with the text tool, or if you just have your dimension on screen, I'm okay with that as well. And then complete the views. So do want to point out, draw a line that would connect the 2 pipes at their closest point and project into the horizontal and frontal views. So show your perpendicular connector in all views just like we did together, and then solve for visibility. So again, just a quick reminder, if I'm solving the front visibility, I start at this intersection and go up. It hits CD first. So in the view where I started my ray is where CD is on top. If I want to solve for this view, I need to start a ray here. See that it hits CD, so CD is also on top in this view. And then the last one is another one similar to this. It used to be 1 drawing, but I separated them into 2 so that you'd have more room to draw. So again, same idea. This one's a little quicker because it looks like you've already got a true length pipe in there, so you can go straight to point view on this one. And again, show your perpendicular connectors and dimension it in the appropriate view. Okay, so that's the plan for today. Let me know if you guys have any questions.